In this video, we're simply going to be discussing the holiday test 1 that I assigned. And for those that can't find it in the group, for those that have not yet attempted, I would advise you to first of all attempt it to see how much progress you are making. And as indicated, every question had its own course code. And this is going to help you to see if you are comfortable with that particular topic. So like for binomial, I did as much as possible dig for hard questions. So meaning if you are able to solve these, you can be proud of yourself to say you're okay with binomial. Then comes to trig. This is just the basic part. There was no sketching here, just the normal part. That's what I added. Then same applies for physics. I just added something that people are familiar with from semester 1. Then chemistry, we have chemical equilibrium. Then we have thermochemistry, and we have kinetics at the end. Yeah, so this is the paper that we're simply going to be discussing in this video. So we'll start with question 1, which is a question from binomial. So in as much as the course code says Math 1100, this is still going to be the same coverage when you learn binomial when you're doing it in 1120. So we start with question 1. Question 1 says solve 2n plus 2 in brackets factorial divided by 2n to be equivalent to 30n minus 34. So question 1, we are simply having 2n plus 2. Then this is factorial, then this is divided by 2n, then factorial. This is simply going to give us 2n plus 2. Then subtract 1 from here, this is going to be 2n plus 1. Then subtract 1 from here, this is just going to be 2n, then with the factorial. Down we still have the 2n factorial. Now because the 2n is together in the brackets and the factorial outside, it simply means these guys are together with the factorial. They are both being affected by the factorial. So this is why we are able to cancel them like this. Now, this whole expression was equated to 30n minus 34, by the way. So we are having a 2n plus 2. Then we are having 2n plus 1. This whole thing is equated to 30n minus 34. Then we can simply expand this part. This is going to give us 4n squared plus 2n, then plus a 4n, then plus a 2 is equal to a 30n minus a 34. And this just becomes 40n squared. This is a 6, so 30 comes this side, it's going to be a 6 minus 30, that's going to give us negative 24n. Then when the 34 comes this side, it's going to be positive, that turns out to be 36. We are now going to have a quadratic. We can reduce it by 4. 4 can divide everything. This is going to be n. This is 6n. Then this is a 9 is equal to that. This can be resolved here using product sum factors. This is just going to be this expression there. Then we are having n minus 3, minus 3, then n minus 3 is equal to 0. In the end, we just get this. This is n minus 3, n minus 3. So it's a repeating root, meaning n was just supposed to be equal to 3. This is what you have. So if you got two answers, one would have been negative, one would have been positive, and you'd have gotten the positive one. Because in the factorial computations, we never accept anything that's negative or a fraction. So this would have been your answer to question number 1. So this is completely done. Here n should have been 3. That's your answer there. Then here they are saying express 9 choose 3 plus 9 choose 7 as a single binomial coefficient of the form n choose r. So this I can just quickly do it from here. N choose 3 plus n choose 7. We're able to see the only two rules here. The rules that you have to think of is the first one is this one. And the second one that we can apply, this is the first one. The second one is that n choose r plus n r minus 1. This should give us n plus 1, then choose r. You notice that we cannot apply this second one because here it's n, but the numbers down do not differ by 1. This is 3, this is 7. So we're simply going to change this one using the first rule to say 9 choose 3 is the same as 9 choose 9 minus 3. That's going to give us the same as 9 choose 6. So using the first rule, that's what we've done. While the other one still remains the same, which is 9 choose 9 choose 7. We are doing this because we want the numbers on top to be the same and the numbers down to only differ by a 1. So you're seeing a 6 and you're seeing a 7. So your n is simply 9. We're going to apply the second one now. This is going to be 9 plus 1, which is a 10. You pick the bigger one between the two, which is just the r, which was 7. Because 7 minus 1, that's 6, right? That's r minus 1. So this is what they wanted to be the answer for your second question there. So hope this is okay. Then number B, they're saying, find the term independent of x in the expansion of this. So you have something similar like this on your tutorial sheet. So the question 1b1, they want the term independent of 3x, then minus, this is 2 over x to the power 8. So remember the formula. The formula is just n choose r, a to the power n minus r, b to the power r should be equated to x to the power 0 when they say the term independent of x, right? And we know the nth term is just r plus 1. So this is 8, choose r, then the first term is 3x. This is 8 minus r, then this is negative 2x to the power r is equal to x to the power 0. Then this right here is going to be x to the power 8 minus r. Then down we're having x to the power r is equal to x to the power 0. We get only the portions that have x. That's what you simply get. So don't focus on anything else. Ignore anything that's not x. Yeah, so here we're just getting the x part. Then here we're just getting this x to the power r, and it's at the bottom. It's like this to the power r is the same as negative 2 to the power r and x to the power r, meaning this is the same as 1x to the power r, right? This is the portion that we are getting, which becomes this, because you are having x to the power 8 minus r multiplying 1 over x to the power r. There's a 1 here, so this is where this is coming from. Because this is down, we have to bring it down. Then, according to this, we're just going to have, if the bases are the same, we simply subtract the power. So this is going to be 8 minus r minus another r is equal to this. So we change this part, right? We change it to be this according to your indices, isn't it? When you have this and you have x to the power m, this is the same as x n minus m, right? Yeah, so that's a principle we used here. Then the bases are the same, meaning we can equate the powers. This is just that. Negative 2r is equal to negative 8, meaning r is equal to 4. So if r is equal to 4, we can come here and put your 4 there. So 4 plus 1 is simply equal to 5. So it is the fifth term which is independent of x. Find the term, so it's the fifth term. We can actually get it, so we can actually show it. The term, we show them the term, the answer we're going to get by just replacing wherever there is r, we put 4 because we found our 4. So we're going to say 4. Then we have the first term is 3x to the power 4. 8 minus 4 is 4, right? Negative 2x, this is the power 4. 8 choose 4. If you solve this separately, 8 factorial. This is the same as 4 factorial and 4 factorial. This will be 3 to the power 4 and x to the power 4. Negative 2 to the power 4. Then you're having x to the power 4. This is just going to give us 8 choose 4. And then times 81, which is 3 to the power 4. Then times your 2 to the power 4, which is just the same as 16. So this is going to give me 9 or 7 this. You have x to the power 4 and another x to the power 4 down. So this will just end up being 9, 7, 20. So this is the fifth term that we're supposed to get. Yeah, this becomes positive because we are having negative 2s, 4 of them, right? So we have to do this. This here, 3 to the power 4, that's simply 9 by 9, right? Because this is 3 by 3, then this is 3 by 3. So this is where the 81 is coming from. So the total will just give you this. This is the answer you're supposed to give them here. That's a 90, 720. That's our fifth term. Then number 2, they're saying, without expanding, find the interval or range of the values of x for which the expansion of this is going to be valid. So this is just a free mark because we're not even expanding. They just want the region of validity. So this is 1 over 2 minus 3x. This can be converted to be 2 minus 3x to the power negative 1. The first term is not a 1, so we have to make it to be a 1. We factorize 2. If you factor out 2, this is going to be 3x over 2. Remember, everything is raised to the power negative 1, right? So now, as soon as you make the first thing to be 1, this is 3x over 2, the power that. So as soon as we make the first term to be 1, whatsoever remains on the second term is going to be the valid region. So we just say the valid region is just going to be modulus of this guy, then less than 1. That's what we have. So from here now, we can separate the number and the letter, which is just going to be this. So if I give you modulus of AB less than 1, you can split them like this if you want. The meaning is still the same, right? That's what we're simply doing. Modulus of this is still 3 over 2 because anything that comes out of the modulus has to be positive. Then at this point, I'll divide both sides by 3 over 2, even this side by 3 over 2, so that I'm now going to have 2 over 3. So this here is the answer that they wanted. This will give you your marks for this question. Here, your 2 marks. So the region of validity is actually this. That's basically what was given on question 1. Hope this is okay. Question 2, again, I added this binomial part just to spice up things to see if people actually understand the concept. So in a binomial expansion of 1 plus x over k to the power n, where k is a positive integer and the coefficients of x and x squared are equal, that's what they're saying, show that 2k is equal to n minus 1, right? So they're simply saying in the binomial expansion of this, where k is a positive integer, the coefficients of this. So according to this, we're simply going to take n to be as follows. So this is what we're going to have. Okay, so question number 2a, they're simply telling us that we need to show that 2k is equal to n minus 1, provided k is a positive integer. So, and the coefficient of x and x squared are simply the same. So this is how we do it. So we know to say, according to the first one, we're saying the coefficient, we're going to have the coefficient of x. This is how we're supposed to get that. X alone. So here I'll just put x. You notice here, there's just an x, right? Then the next one is the coefficient of x squared. It's supposed to be the same. You notice the only difference is here. The coefficients, meaning the numbers in front of x and x squared, are supposed to be the same. So we're going to use these two expressions, the first one and the second one, just to know the value of r that we're interested in. So according to the first expression, r is simply going to be equal to 1 because x to the power r, then x to the power 1, right? So the powers are simply the same. On the second case, x to the power r and x to the power 2, meaning r is equal to 2. Then we come back. We just replace in the first part. So here, if you notice, I ignored the other portion. So here, this whole part, wherever there's r, I put a 1, this part. It should be the same as when we put r is equal to 2 in the second equation, because they're saying the two coefficients are supposed to be equal by the time we're done solving. So this is us equating the two. And since they just meant coefficients, no wonder I ignored x's here. So we're saying if you remove this x and remove this x squared, what is going to remain is this. So you know this guy can change to become n factorial and n minus 1. And the second one can also change to become this. There was this, so this has gone. It's like this k, I mean these x's have gone. So it's like you have something like this. That's what I mean by the coefficients, right? The numbers in front of x and x squared are supposed to be the same. So now we're supposed to equate them because they should give us the same thing. So when you express this to be equal to that, you notice that the down part can be further expanded to be n minus 1. I cancelled this, by the way, because they appear on both sides. 1k as well here and 1k there to give us no k here, and then a 2 and a k this side. N minus 2 can cancel this n minus 2, so we're remaining with this. When you cross multiply here, that's why you get your 2k is equal to n minus 1 as required. So that's the only thing that they wanted here. Yeah, so first of all, you're going to write an expression for x. Get the error first. What term has x? Again, get what term has x to the power 2. Get them. Then once you're done, you have your error for this. Your error is 1. Your error for this one, error is 2. Replace them and equate the coefficients. Now here they're saying if n is equal to 7. So if we put 7 there, so 2k is equal to n minus 1. So if n is equal to 7, what is k going to be? So 2k is equal to 6, 2, then 2, so meaning k will just be equal to 3. Wherever there is n, we just put a 7, that's what they wanted. Yeah, the number B, the last one here, this is actually B. So B, they are saying find the term containing x to the power 2 over y to the power 2 in the expansion, the binomial expansion of this. So this is a little bit interesting because we're used to finding the term independent of x, or just when you're dealing with one variable, right? So here they gave us two variables, x squared over y squared. So we're saying we have x over y minus, this is y squared over, and this is 3x squared, then to the power 8. So we're saying a choose r, then we're having x r to the power 8 minus r, negative y squared, 3x squared to the power r. So here we're just going to equate this to x squared over y squared. That's what we are going to do. The same thing that we do when we're looking for the term independent of x, right? Or the term that has something, let's say this, like your question number, is it 13 on your tutorial sheet? So those type of questions, that's what we do here. Just that the term we're interested in is having two variables. So you can just decide to focus on one particular variable because x and y are having the same power here, right? So I'll just decide to focus on x. That's what you can simply do all the time when you're given such a question. So I'm going to focus on x. I'm going to write only the portions that have x. So there's x to the power 8 minus r. Again, there's this x down here to the power 2r. So there's x 2r, 2 times r, right? This should be equal to the x which is on top there. So I'm only focusing on x. Then from here, I'm going to say since the bases are the same, I can subtract the powers. This is just x to the power 2. Equate the powers. This is 8 minus 3r is simply equal to 2. Negative 3r is equal to negative 6, meaning negative this, negative that. R is equal to 2. So if r is equal to 2, you know the term that has this, meaning 2 plus 1. So it is the third term that has xy over y squared. X squared and y squared are simply found with or alongside the third term. So that's basically what they wanted here. Yeah, so please, you can play the video in slow-mo to try to get what we are discussing, and if anything, try to attempt first. So these are just like one of the tricky questions you may find under binomial because you are familiar with the usual, like Pascal's triangle and everything else. So they'll try to twist things you already know. They just bring them in a funny way to make you overthink. Yeah, so that's what you have. Even if you were to focus on y here, the answer would still be the same. So let's say I show you here, if instead of x I decide to focus on y, let's say I pick anything that has y here, anything that has y. So here there is no y, is it? Or there is a y here down, right? There's a y. Yeah, so there's a y here. So I'll say 1 over y to the power 8 minus r, because this y is at the bottom, right? On top there is a y there, this y. So there's a y, then 2r is equal to, this is what? 1 over y squared, right? So this right here is going to be the same as y 2r minus 8 minus r. So 2r minus this, so 2r minus 8 minus r. That's how this is becoming positive, because negative times negative is what? Positive. This right here can be written like that. If we change it, we just want to see the bases to be the same. So you have 3r is equal to 8 minus 2. 2 plus 1, that's a 3. 8 goes this side, becomes positive. So it's going to be, we're supposed to have this. This is what we're supposed to have. Then we solve it like that. this is still going to end up to be the same. R is still 2. So either ways, we're just saying the outcome has to be the same. Yeah, so this is what you had on binomial. Then now 1120, there was this question on trigonometry. They're just saying, find the exact value of 5 pi over 3. So the first thing you have to do here is to, first of all, convert the 5 pi into degrees. That's the best way to do. When you convert it to degrees, it will be easier for you to work it out. So we know the conversion factor here. 1 pi is equal to 180 degrees. So 5 pi, this is just going to be 180 over pi. So this is the same as cos 300, right? This is in the fourth quadrant, and cos in the fourth quadrant is positive. So this is just the same as positive. Cos 360 minus the what? The 300. Remember, we don't use calculators, so the only thing you know are special angles. And if you look at cos 60 from those special angles that you know, your 60 is there, you have root 3, you have 2, you have 1. Cos of this is adjacent over hypotenuse, so this is just going to be half. So that's basically what you have. That's the answer to the first part there. Then the next one is an identity. They just wanted to, it's in an equation form, but we have to first of all remember our knowledge of identities before we're able to evaluate this. Or in simpler ways, if you want to think of it, you can it's up to you, you can just let k be equal to tan x. That's the easiest way to do it. So this is going to be 2, then k, then plus 3 is equal to 5, then plus k, right? You can do it like this if you want. This is 2k plus 6 is equal to 5 plus k. This is 2k minus k is equal to 5 minus 6. So this is just k is equal to -1. So tan x is just the same as -1, meaning x is equal to negative. Tan inverse of -1, this is just going to be -45. So we know tan 1 is, tan 45 is 1, right? That's what we know from our special angles. So according to this, the negative is just telling you the quadrants where this tan is being found. Where is tan negative? Tan is negative in the second quadrant and in the fourth quadrant. So the angles we need to get is not, the angle we need to get is not 45. We just need to use 45 to get what we're looking for, where tan is actually negative. So we're simply going to get 180. We say 180 plus the -45. Yeah, so it's 180 literally minus 45. So the answer is 135. That's what you get. That's 135. Because if you punch tan of 135, you notice the answer is -1, right? That's what you get. Then the next one is simply supposed to be 180 plus the 45. That's 225. Because if you punch tan of 225, so this is going to be, this is going to be where, this is supposed to be in the fourth, right? So in the fourth, 225 will give us +1. We need where it's negative. Yeah, so we're going to have what? Is it 360 minus 45? This is the 315. So the other answer is actually 315. Because if you punch tan of 315, you simply get a -1. Yeah, so these were supposed to be your two answers for number 2. In between 0 to 360, the only place where tan can give us -1 is in the second quadrant when we're using 135, or in the fourth quadrant when you use 315. So that's basically what you needed to do there. Then this one here, we can just evaluate this using a particular triangle. So they've already given us the quadrants where these guys are coming from. Alpha is in the second quadrant, so this is supposed to be coming from the second. Then beta, so this is alpha. Then beta is in the third quadrant, so we know this is the third quadrant we're dealing with. So sine alpha is equal to opposite hypotenuse, so this is going to be 3 squared is equal to 1 plus, let's say, x. This will be a 9 minus 1, which is 8, square root of 8. So this is just going to be 2 root 2. So this is 2 root 2 there. Then this cos b is equal to adjacent of hypotenuse. So this is going to be 5 squared is equal to 4. This is 25 is equal to 4, then plus x squared. And so give us what? A 1. So x is equal to root of 21. So this is what we have. We make the triangles first. These are very important for you to be able to get the right things. Yeah, so we need to pay attention to the quadrants we're dealing with. So like the question they're asking here, cos alpha. So we know what cos alpha is. Cos alpha plus beta, that's just this. Then minus sine alpha, then sine beta. So cos alpha is adjacent. So this is 2 root 2 over hypotenuse, which is 3. Cos b is simply negative 2 over 5. Minus sine alpha is simply 1 over 3. Sine beta, that's root 21 over 5. Then from here we can just add these guys, which is negative 4 root 2 over 15 minus root of 21 over 15. This will be negative 4 root 2 minus root of 21 over 15. This here is the exact value of what they wanted there with respect to. So I must pay attention to, let me pay attention to the fact that I forgot to ascertain whether the thing we are using is. So this is cos alpha, right? Cos alpha in the second quadrant, cos has to be negative. So there should have been a negative here, right? So this will come out to be positive. Then sine, this is what? This is going to be, this is sine alpha. Sine alpha is already there. Then sine beta. So sine beta, we're dealing with the third quadrant. So sine beta also has to be negative. So this is going to be positive there actually. So yeah, everything has to be positive. This is how we're supposed to do it. Yeah, so you can just pause the video to attempt. For those that have not yet attempted, you can try to attempt sine 2 beta. We learned this guy here, sine 2 beta is the same as 2 sine beta and cos beta. This is just 2 sine beta is opposite. It's in the third quadrant, so we have to put a negative. Then cos beta is already here, negative 2, 5. This is going to be 4 root 21, then over 25. That's what you get. So these were supposed to be your answers for these two questions on trigonometric equations and identities. So this part here, the physics part, they're saying explain how a body moving at constant speed can be accelerating. Okay, so a body can only be in at a constant speed and accelerating because of the change in direction of velocity. So this is because, we just say because change in direction of velocity, because this statement here is only applicable when something is moving in a circular path. It will not apply if something is moving in a linear path, because remember, those are velocity time graphs that you do. If something is moving at a constant velocity, this area here, so this part from here to here, that's constant velocity, right? There is no change in velocity because we know acceleration is just this, right? So this is going to be the change in velocity is simply going to be 0 over time, so 10 minus 10. So at this particular point, there is no change in what? In velocity, hence acceleration is going to be 0, but there's distance being covered. Now this can only be explained in terms of circular motion, because in circular motion, the velocity could be the same. So velocity, remember how we get centripetal velocity. So if centripetal acceleration, I mean, the velocity could be, let's say, 20 meters per second, but it's going to be changing. This is what we mean by direction. The position it's at will determine what we are having. So we have those phases. Yeah, so this is the basic reason that you get as to why a body at a constant speed is still going to be said to be accelerating. Then look at question number 2. So question 2, they're saying an aeroplane carrying out a parcel drop releases a parcel while traveling at a steady speed of 90 meters per second at an altitude of 200 meters. Calculate the time between the parcel leaving the aeroplane and striking the ground and the horizontal distance traveled. So we are going to take this as a best case scenario. Best case scenario is that our airplane is somewhere there. So we're just saying it leaves the parcel. The parcel won't directly come down just like this. No, because of air resistance, friction, it will come like this. Then for until we have a particular, so a distance from where the airplane was when it was releasing the parcel. So this is just going to be something that looks like this. This is the scenario that we're looking at. So this is the pathway of our parcel. So if you look at the velocity given, we are given 90 meters per second. That's the initial velocity which we are starting with, 90 meters per second. And the total distance, the height rather, is simply 200 meters. So first of all, we have to get the time it takes for it to reach down. So if we're covering 200 meters and the initial velocity is this, we don't have the time, plus half. We're going down, so we're going to use 9.3, then t squared. We're going to use this to get our time. This is 90t plus 4.96, then t squared. Then this is 4.96 t squared plus 90t minus a 200 is equal to a 0. This is just going to be t is equal to negative 90, then plus or minus the square root of 90 squared minus 4. This guy, then we have this over 2 times 4.96, which is the same as 9.8, right? Yeah, when you multiply it back, so this is 9.8. This is just going to be, so a point of correction on the 4.96 is just supposed to be 4.9. When you have 9.8 here, yes, it's just supposed to be 4.9. So we're turning this into a quadratic. Then if we say our 90 squared, then minus, we'll have 4 times 4.9 times 200. So this initial has to be minus, but because there is a, so it's supposed to be 90 squared. It's supposed to be positive because the 200 is going to make everything positive. So this is plus. We're having a 4 times 4.9 times the 200. This is going to give us plus or minus 12020 divided by 9.8, negative 90 plus or minus the square root. That's a 109.6357. Then we have 9.8, then this is equal to t. So we're having negative 90, then plus 109. So we'll just say our previous answer minus 90, then divide it by 9.8. So the first answer we're getting that makes sense is 2 seconds. Then the other one will be wrong because time can never be negative, right? So we cannot have this. So we discard the other part. Discard t to be negative 90 minus 109, then over 9.8. So we discard this one because it's going to produce a negative time, which is wrong. So if the time is 2 seconds, that's the time it takes for it to fall down. We can simply get the range. So according to this, we're just saying the total distance that we're having, the velocity is this, 90 meters per second. Then from here, okay, so on this guy here, after much consideration, you notice that the previous part that I'm doing, I'm going to correct the statement because here they're saying, I didn't see this. So an aeroplane carrying this parcel drops it, releases it, right? While it's traveling. So it's the airplane which is traveling at this speed. So meaning it's like we consider it to be a particle, right? So it's already moving with 90 meters per second. Then it drops something, right? So it drops the parcel. So it just releases it. We don't push it down. We just drop it. We just leave it, release it from the air. So when we do that, the velocity with which we are releasing it with is simply going to be the maximum velocity at this point, which is just 0. So the velocity of any particular particle when it's at its maximum height in the y-axis, so here in the y-axis is going to be 0. In the y-axis, it's this part, then in the x-axis, it's been given to be 90. This is the velocity of the plane that is moving with. We just release the parcel down by 0, right? So if we use 0, we're simply going to say the distance is ut plus half, then g, this. Then we know this part is 0 because initial is 0. So this is the part we are having. The total time you are going to get for the parcel to reach the ground after, if it is at a 200 meters altitude, it's simply going to be 6.38. Yeah, so this is basically what you get when you solve this part here. There's no starting part because the initial velocity is 0. We're just releasing the parcel. Yeah, so I made a mistake in the previous thing. Then here we're asking for the range. This is the only way it's going to make sense. The range, remember the formula for the range, the velocity in the x times the total distance. So the velocity in the range is always going to be constant, which is the 90 that the airplane was moving with. That's the velocity that the parcel had as well. So now when we multiply this on the time, it will give us this distance. So it was 574.999 meters away from the position that was it was released from in terms of in the x-axis. Yeah, so this is how you were supposed to do this. So please take note of that correction. Then number C, a car towing a caravan travels along a steady speed of this. If the force exerted on the engine is 2, what is the power output? So we know what power is. Power is equal to what? Work done over time. Then we know what work is. Work is simply force times distance over time. Then you know the force has been given. Distance over time is the same as what? Velocity, right? So this is just the same as force, which is 2 times 20, which is just going to be 40. This is what? They're asking for power, right? Power is measured in watts. So this is going to be watts. Yeah, so we put this. This is basically what they wanted. For you to just figure it out that power is the same as force times velocity. So that's your question number 4, which is from physics. Then I'll look at your next question, which is on chemical equilibrium. So here they are saying a vessel contains 0.0222 more phosphorus trichloride. Then we have phosphorus pentachloride and this chlorine. These are values at equilibrium, right? We need to divide each one of them by the volume, because we need to get the concentrations, right? So I'm going to divide the first one. This one is 0.0222. I'm dividing it by 6. The next one, chlorine, is 0.1044. I'm dividing it by 6. The next one, 189, I'm dividing it by 6 as well. So if we do that, divided by 6, this is giving me a 3.7 times 10 to the power negative 3. Then the next one is 0.1044 divided by 6. This is also going to be 1.74, then by 10 to the power negative 2. Then the last one, 0.189 divided by 6. That's 3.15, then times 10 to the power negative 3. So now, according to this, remember that these are in gaseous state, right? So if they're in gaseous state, the only thing you can get is Kp, but we're using concentrations here, right? So Kp can be gotten if you have pressure values. So meaning what we actually need to get is Kc. Kc is given such that we're going to say the concentration of the pentachloride, phosphorus chloride, over the two guys here, which is the PCO3, and then we have the chlorine there. So if I do the replacements, I'm getting my Kc to simply be 3.15, then times 10 to the power negative 3, divided by the guy down is simply 3.7 times 10 to the power negative 3, then 1.74 times 10 to the power negative 2. When you punch this, you simply get your Kc, right? So punching is very much necessary. The skill of punching correct things is very important because most people make mistakes here. Yeah, so the first is the denominator, which is 3.7 times 10 to the power negative 3, or rather let's just put it the way it was, which was 0.0037, then times this other one was simply 0.01, then 74. That's what we have. So this will simply give us a 48. Our KC is 48.9, which is the same as 49. So if this is your KC, you know what your KP is going to be. KP is equal to KC, RT, then delta N. You know to say your KP is going to be your 48.9. Your R here is 0.08208. Your temperature is supposed to be in Kelvins, so we just say 230 plus 273. That's going to be 503. Then this is going to be, there's a 1 here minus 2. This is 1 plus 1, right? Your delta N is just 1 minus 1 plus 1, which is just negative 1. So this is basically what you have, 0.08206. Then when you get this, the reciprocal of that, multiplied by a 48.9, my answer is 1 point something. So KP is 1.184. That's your KP. Yeah, so this is how you were supposed to do number 5. For those that are taking Chem 1010 under equilibrium, this is what you need to do. Then look at this part. The only thing I was interested in is simply the last part. They're saying propanol, this guy here, is given under complete combustion. In an experiment, you calculate the enthalpy change of combustion for propane. 2 point, this of propane was burned completely in oxygen. The heat energy from this combustion rise from 200 grams of, raised the temperature of 200 grams of water. So this is what you have. The specific heat capacity of water is that. Calculate the heat transfer to raise the temperature of, so the heat. So what is the heat needed? So the heat needed to raise the temperature. The mass of water is what? So we're saying the mass here, calculate the heat energy transferred to raise the temperature of the 200 grams of water from this to that. So just put the 200 grams of water. Then the specific capacity is 4.18. Then the temperature is 78.4 minus 20.2. Remember the formula, Q is equal to MC delta T, right? So this is basically what you need here. So this is a 200. They specifically wanted the heat for water. That's why we're just using 200. If they wanted for the whole solution, would have added the propanol 2.9 and the 200 grams. Yeah, then multiplied by your 78.4 minus your 20.2. Yeah, so the answer that we're supposed to get, okay, so my calculator is tripping. So 78.4 minus 20.2, get our answer, times 4.18, get our answer, multiplied by 200. So the final answer I'm getting here is 4.8655 times 10 to the power 4 joules. This is basically what you have. Then here they are saying calculate the enthalpy change for the combustion here. So the enthalpy change, so Q is equal to the enthalpy, right? So specifically this is the heat transferred with respect to water. So if this is the amount of heat transferred to water, it's the same amount of heat transferred to the propanol. So we're just going to say it's the Q you got divided by the number of moles. So the Q you're from getting 4.8, then you're saying 655 times 10 to the power 4 joules. Then we're dividing it by what is the Mr for propanol is given, right? So you have the Mr, get the moles, number of moles is equal to the mass, which is 2.9. That's when we use the 2.9 over the Mr of this guy. You get the Mr, put it there. The answer you get here, you're going to bring it down here. Then those moles. So the answer has to be joules per every single mole of propanol. That's how we get your enthalpy of the reaction. Yeah, so hope this is okay. Then the last one, they're saying for the reaction A plus B to be C plus D carried at a constant temperature, they want us to get the order of A and B. So remember what we do here. We first of all choose two trials where one concentration is changing and one is kept constant. So this is just going to be experiment 1, 2, and 3. So we're going to choose 1 because this is changing and this is kept constant, right? So if I divide this, that's going to give me half. So I'm just going to do it first. Then this side, if I divide, that's going to give us half as well. So this, by the way, is on A. So only A is having something there. So we say the power we are getting is, let's say, this is half an M. So meaning M is equal to 1. So the power on A has to be 1. That's what we have. Okay. So there's a proper way. I'm just doing it fast because I'm assuming that you already know here. You just have to verify your answers, right? Yeah, so N is 1. I'm choosing that to be that. Then I'm going to choose these trials as well. So these are going to cancel, which is just a 1, I mean. So yeah, this is just going to be a 1. This goes away. This gives me half as well. And this side, I'm getting what? I'm getting a 3. That's 1 over 4. Yeah, so that's 1 over 4. M, so this can be 2 negative 1 is equal to negative 2m. Is it? Am I doing the right thing here? Okay, so the m has to be here. The m was supposed to be there. Yeah, so that we can say this is now that. So m is equal to 2. So for B, it has to be 2. So the correct answer here is just your C. That's basically the correct answer. So this was just a bonus question I had added. Yeah, so thank you so much for watching. For those that are not yet registered or in need of lessons, you can feel free to contact me for lessons. But for those that are submitted and you didn't get feedback from me, this is what you are required to do. For those that are in need of further clarification, you can come to my DM, then I can just schedule a class with you in case you have any particular topic, or I can send a recorded video on any particular topic that you feel uncomfortable with. So thank you so much.